So SCN. So when an AP gives you how to draw the structure, okay, they will be pretty like, they're gonna be guys. They will be like not too like hard on you guys, okay. So typically when they ask you this, I mean they kind of give you the position of these guys where they should be in. That's relatively easy, right? So like sulfur on the side, carbon in the middle, nitrogen on the one side, guys. So this is not gonna work for some of us. It's not gonna work. Let's provide this with minus charge. SCN minus. Okay. So because yeah. So why I think guys it's not gonna work? Like why do you think guys? I'm thinking like okay you can't drill the loose dot. I mean you can. But what's the problem, guys? You will probably have what guys? Odd number of electrons. Because this guy will have 6 valence electrons, this guy has 4, this guy has 5. Which does have 15 electrons overall for the valence electrons. So it's not going to work. Okay, so which means like you can't have the octet because you have an odd number of electrons overall. So now if you look at it, guys, here 6, 4, and 5. So that's why I gave one more, which is plus 1 here, which is now you have 16 electrons overall. So now you have to complete the octet with the 16 electrons overall, and how you do it. So if you look at it, guys, my recommendation was you fill the electrons on the outside first, like this, and then complete the octet. All right, that's what we talked about. So you look at it, guys. So yeah, so now the carbon doesn't have the octet right now. So how do I go about and do this, right? So so if I give them a double bond from both sides, okay, let's take a look at this. So if you look at this. And then you gotta calculate the formal charge of this, because that's literally what they're gonna ask you. Oh yeah, like draw this based on the formal charges. So if there's double bond between the carbon and nitrogen, so carbon is good. Carbon is 0, so, but for the sulfur, okay, it'll be 6 minus what? 1, 2, 3, 4 minus 1, 2, 3, 4. Okay, I'm sorry. 6 minus, there are 2 bonds here, so minus 2, 1 bond, 2 bonds, 1, 2, 3, 4, minus 4, it'd be 0. So this guy's happy, this guy's happy. Okay, now it becomes the nitrogen, right? So nitrogen is what, guys? The double bond here also as well. So nitrogen is what? 5 minus 1, 2, 3, 4, minus 2 bonds, 1, 2. It's minus 1. The formal charge is minus 1, 0, and 0. They're relatively good. Okay, so now, based on the formal charge that we talked about, so is this the shape, of the SCN? It's called thiocyanide, by the way, okay? Thiocyanide. So is this the best structure, guys, that they can give you guys? I think so. Because what? Nitrogen here has what? The lowest, so you gotta understand, guys, okay? First thing first, based on what we talked about, if you add the formal charges for all, it should add up to the total charge of the molecule, okay, which is a minus 1, right? And now, if you think about it, right? As we discussed, so it's better to have a 0 or minus 1, or you cannot have a 2 here. Okay, 2 is really not good. So again, there must be a minus charge here. So who gets it? Well, who gets the minus charge as well? Okay. Yeah, the one that has the what? The greatest electronegativity. And nitrogen does have high negativity, guys. So this guy should have minus 1 charge. Okay, so that's the likely shape that I think you should be able to draw for thiocyanide. Ion perspective here. So again, you could have draw like this, triple bond. Okay, that could be one of the shapes you could possibly draw, or what? Triple bond here, and this. So which one is it? Is it this guy, this guy, this guy? Which one is it, right? That's one of the stuff that we talked about. And now if it's this, it'll be 0 here. It'll be 0 here. This is minus 1. Okay. If it's this, I think it'll be 0 here. It'll be minus 1 and plus 1 here. So again, this is not good. This is a minus 1, but it's compared between these two. But I think because nitrogen has a high electronegativity, that's a better shape. Okay? So that's one of the stuff that I think we talked about as a formal charge question, last week, right? Any questions that you raise? Any questions, concerns? I was telling the other student, by the way, other past class right now. I feel a little better right now, guys, but I tell you guys, I live by the water, by the way. This is like Long Island, right? It's nothing, whatever. But I live right here. by the water. This is Atlantic Ocean. Okay, Long Island. I don't know what's wrong, guys. By the way, like, and this is the Bronx, actually. Okay, and you guys, I don't know if you guys know about the Bronx, guys, and don't go there. But I don't know. They've been playing music until like 5 a.m. Like, dude, like, I'm not kidding. If it's my neighbor, like around my neighborhood, like here, then we can complain. But it's across the water. You don't understand, man. Dude, I tell you, like, it was going on until 5 a.m. last night, and like you can see my when I went to sleep. I went to sleep at 5:07 last night and woke up at 7 a.m. So I got like literally 2 hours of sleep last night actually, because I couldn't go to sleep because of them. You don't understand, like I it's like some sort of like, you know, like Mexican music, I think. I don't know. So, dude, I tell you, like people try to call police, but they're saying like it's not in the precinct. It's across the water. So it's like, so guys, like my head is not like all there today, by the way. So, you know, I might have made some mistakes. Hopefully not, but you know, but yeah, I'm not like 100% today. So, you know, I was saying to the other kids too, like only time that I really like pull an all-nighter in my life was in my freshman year during the finals. That was the only time actually, but I never got like 2 hours of sleep in my life actually. But like, dude, I tell you, like, I thought living on the water, you'd think like, you know, like, okay, so it's gonna be quiet, there's no music, it's like you're by yourself. Like, who would expect, guys, like the neighbor across the water is gonna be super loud? I don't know that. Hope it doesn't repeat, I don't know, we'll see. But if I make mistakes, guys, I hope I don't, but I'm not 100% today, guys. All right, so that's why to drink coffee today. All right, so the topic today, guys. Okay, we're not gonna do Lewis dot structure anymore, guys. So the topic today will be on hybridization. Okay, so hybridization, guys, and then. So this is a big topic for you guys all for the AP, okay? And then we're gonna talk about the shapes of the molecules, you know. So that's what's gonna be, guys, for today. This is not easy, by the way, but it's AP Chem, it's not too bad, okay? And then after we talked about this, the shape of the molecules, you know, the hybridization and the shape, the bond angle and stuff like that, we're gonna start talking about the intermolecular forces, okay? And like probably you guys all know, like hydrogen bonding, you know, and stuff like that. If you're cold, like you might want to move back or come up or something like that, okay? And then after that, guys, homework is assigned. I think there are around like 40 multiple choice questions for the homework. I'm not assigned that, I don't think I did. And then I'm gonna move on to gas chapter, okay? So the gases, and then we'll have the gases, and we're gonna have stoichiometry. That's the next chapter that's in line for us, okay? So, yeah. When I was in high school, like I don't know, like like when I was in high school, like I don't know if they still do that. The 4th floor is the math floor, right? Yeah. Right. So back in time when the math floor was still like, I think it's still 4th floor, right? When I was in high school, they used to turn the AC every year, all year, because they want to make the students like awake. And not I'm doing that not because of that, but I'm just hot when I'm teaching. But it's, at least you guys are awake, guys. All right, so I don't know if they still do that. You just don't see them complain now. I don't know. All right, so hybridization, guys. Let's talk about this. What it is. So just like how the resonance was an issue, okay? Resonance was to, like, you know, to patch the not a mistake, but something inconsistency with the atomic orbital understanding with SPD and stuff like that, right? So you guys understand what I'm saying, right? So hybridization was what, guys? If you draw SO2, this is what it was, right? If you just follow the rules of the electron dot structure for the octet and stuff, that's what it was, right? But the problem is what, guys? The problem is there's a double bond, there's a single bond, right? So is it truly a single and double, guys? It wasn't, okay? That's why we had to introduce, you know, a resonance structure, which is kind of, I don't know, not really very smart, but introduce this and, you know, resonate between these two, 50%, 50%, and that's what the structure is with the Lewis dot. That's what resonance structure is, you know, to patch the inconsistency with the actual molecule shape versus the Lewis dot, right? That's what it was. So same thing kind of goes for this hybridization, okay? Just so you have to understand where this comes from now. So let's talk about, guys, this one is important, by the way, okay? Hybridization, guys. Let's take a look at, guys, easy way to understand this. You don't have to really know like the crazy amount of this. You just have to understand the high level of what it is. CH4, methane gas. It's very easy to draw this, right? It's very easy to draw this, guys. But now, let's take a look at carbon. Let's take carbon, guys. So carbon has 1s2, 2s2, 2p2. That's the valence electrons, right? And those are the electrons that are eligible for bonding, right? So now, if you look at 2s and 2p, this is 2s orbital, right? 2p is what, guys? It's got 3 orbitals, right? We talked about this, guys. I'm not going to repeat this. This is 2px, py, pz. Okay, 3 axes here. That's the name of the orbitals. Not name, but x, y, z axis of the orbitals p. So now you've got 2 electrons here, 1, 2, Hund's rule, 1, 2. That's what it looks like. So now, the Lewis dot of carbon is what, guys? Looks like this. So the Lewis dot came from these orbitals, guys. So this is the s orbital. These are p's, px, y, z, right? So they got 2 electrons in the s. Okay, p, x, p, y, p, z, right? So there's 1 here, 1 there. That's the Lewis dot. That's where the Lewis dot came from. Okay, these orbitals, right? So now, like, you gotta understand this. You gotta understand this. Okay? Dude, I'm on like camera, it's being recorded, guys. I'm not kidding, okay? So you gotta understand, guys, here. But so in terms of an energy perspective, right? In terms of energy perspective, guys. So S is at a lower level, 2s, and P is what, guys? Is at a higher potential energy, right? So S is lower, P is higher. Okay. So right now, guys, there are 2 here, there's 1 here, there's 1 there. Okay. So now you gotta understand, guys. Okay. When carbon is about to bond, okay, like, dude, I'm not kidding, guys. Because I read the textbook, I try to explain this a little better. But when the carbon is about to bond, what happens, guys? The electron on the one of the s will shift out to a z, one of the p orbital. Okay, so which means, like, okay, so when they're about to bond, it doesn't make sense, but it supposedly it does according to the textbook. Okay, that's what happens. They made it like sound professional, but I can't explain this in how they explain it, guys. Okay, so again, the carbon's about to bond. What happens, guys? One electron here shifts out over there. That's what happens. Okay. And so basically what happens, guys, if you look at it, guys, so then there's 1 electron on each of the carbons. 1 at S, 3 at P's right now. That's what it looks like right now, okay? And now, you gotta understand, guys, okay? Based on, okay, atomic orbital theory, okay, right? Electron is what? What is electron, guys? Electron is what? Electron is a wave. There's an electron is a wave, okay? So now, if electron is a wave, how are they going to share the electron? Like, think about it. You gotta think about this, okay? How are they going to share electrons? Okay, so they call what? They mentioned what? Okay, so electron is found in something we call the orbitals, right? So they got an orbital, they got orbitals. Okay, what happens, guys? In order for them to share the electron, the orbitals must what? Overlap. What's what I'm saying here? So what I'm saying is, hydrogen has what? S orbital. Only. They got no p's, right? Carbon has what, guys? Carbon's got what? Like p orbitals and like you know, p orbital, s orbital, right? So the orbitals must overlap. That's where a covalent bond is created. Do you understand what I'm saying? So the understanding is, okay, hydrogen has the s orbital. So the orbitals must overlap. You know, s orbital of the hydrogen and s orbital of carbon. Same thing here, right? So you have a s orbital of hydrogen. Okay, so that's overlapping. So, and same thing goes for here, right? So the hydrogen here, s orbital of hydrogen, and hydrogen here, s orbital of hydrogen. So that's the overlapping, okay? So now, but you gotta understand this, okay? So now we have what? Hydrogen filled in these guys. That's what we call the octet. Because of the overlapping, now they're sharing the electrons in what? Because of orbital overlapping, okay, of the hydrogen s and p of, like, you know, of the carbon and also the s, That's what they call a covalent bond, based on the atomic orbital understanding, right? But but you guys have to understand what I'm coming here. If you look at this, this is what guys? S orbital of the hydrogen, S orbital of the carbon. Do you see that, guys? What about these three? 3 is what, guys? S orbital of the hydrogen and what? P orbital of the carbon. Do you understand, guys? So you gotta understand, guys, okay? This bond should be different than these 3 guys. Because what? Like, dude, like, okay, so this is all the carbon orbital, this is all the P's, same level. Which means what? If you compare the energy of the bond, they should be different. These 3 are same, this one is different. You understand, guys, what I'm saying? Is it different? What do you think, guys? Absolutely not. It's not different at all. So, which means one bond should be at a lower potential compared to the other 3. Based on the atomic orbital understanding, right? Like, it makes sense, right? That's what it was. Is it making sense at all? No, it doesn't make sense. Because what? Every bond is what? Same energy, same length, nothing different. Okay? So what do they do, guys? They introduce what? Hybridization. Orbital hybridations, which means what? They're mixing it. They're mixing the orbitals here. So in a high level, what's happening is what, guys? So instead of having 1s and 3 separate p's, what are they doing, guys? They say, oh yeah, when they bond, they get mixed up. They hybridize. Instead of this. So it happens with the carbon. The carbon will have 4 orbitals of the same energy, okay? And these are called what? These are called sp3. sp3 orbitals. You got 4 sp3 orbitals. Okay, so carbon's got what, guys? 1, 2, 3, 4, sp3. So why is it sp3? Because what? 1s orbital, 3p orbital has been what? Mixed together, involved in bondage. That's why it's called what, guys? sp3 orbitals. Okay, so and that's what? Yeah, they mixed it up, which means what? They have the same energy. Okay, that's what they call hybridization of the orbitals. Okay, but why do we talk about it? Because what? Yeah, this inconsistency of what? Atomic orbital model that we know. Okay, so now what happens, guys, if you look at the shape again, carbon is what, guys, now? When the carbons are at the bond, the overlapping, okay, so the carbon has like these orbitals, okay, and these are what, guys? If you think about these guys, what happens? This is what? Now, so if they ever ask you the covalent bond between the carbon and hydrogen, what orbital overlaps? They'd be what, guys? S of the hydrogen and what? sp3 of the carbon. That's the overlapping of the orbitals for what? Carbon and hydrogen. Because what? The carbons or carbon orbital has been hybridized. That's the understanding of hybridization of the orbitals. And you have to know this for AP Chem. They will ask this in the question. I mean, they will not ask you guys like explain hybridization. They're not gonna do that. They're gonna ask you this atom in the molecule, what is their hybridization? Is it sp3, sp2, sp1? That's all they're gonna ask you. So that's basically, I mean, I'm just giving you guys where this came from. So I'll be very simple with this for you guys to understand. You guys, you might not even have to know this, okay? So, like, meaning like where it came from. If you understood, great. But now let's take a look at this, guys, okay? The important thing of this is actually understanding what hybridization is, potential atom. So the stuff we drew before, okay? Stage 4, okay? Stage 4, we understand, guys, when you draw this, 1, 2, 3, 4. And also, guys, NH3, also nitrogen, guys, one pair, hydrogen, hydrogen, hydrogen. Also H2O, water. So if you look at these guys, okay, how do you determine the hybridization of the, so typically, guys, the central atom, right, are the ones that gets hybridized, okay? Not the satellite ones like this. Hydrogen right there, okay? How do you determine the hybridization, guys? This is what it comes down to. So they call this, guys, sometimes they call it, you know, they call this a steric number. Okay, the term is, I mean, nothing fancy, guys, nothing fancy, steric number. Okay, so what it is this, okay? all you have to do is count how many things are surrounding the central atom. Do you see that, guys? So which means what? Carbon has what, guys? 1, 2, 3, 4. Okay? There are 4 things surrounding central atom. Okay? Which means what? The steric number is what? 4. The 4 is the steric number. Okay? 4, this guy. So when steric number is 4, okay, the shape of the molecule becomes tetrahedral. So again, you understand, guys? Whenever you have a steric number 4, okay, it becomes S1P3 hybridization. Every time. There's no constants here. It's always sp3. Okay, S1P3. So how do you determine this, guys? If you add these numbers, okay, S1P3, sometimes they just write it as sp3. But now if you add these numbers, they have to add up to the steric number. It's very simple stuff. It's like nothing fancy, okay? And keep in mind, guys, whenever you have an sp3 hybridization, the shape is always tetrahedral. Always. Their shape is tetrahedral shape, okay? So tetrahedral, guys, again, like this is something that you might want to just read a textbook or something. So tetrahedral, guys, looks like this, okay? So this is a little tripod like in a tripod, and what? There's one sticking out like this. That's a tetrahedral shape, okay? So if you look at it, so the bond angle is one of these bond angles is what? 109.5 degree angle. Okay, that's one of the tetrahedral shape that you get to know. So if you it's not a flat shape. That you cannot explain this tetrahedral shape with a flat structure. Okay, so meaning, guys, it'd be more like this. Hydrogen here, guys, and there's a hydrogen here, and there's a hydrogen sticking out, like protruding outward, and there's one hydrogen going backward. Okay, so that's like tripod, and there's one sticking up like that, and the bond angle is 109.5 degree angle. That's what that angle you have to know. You have to know the angle, because that's something that you have to know for the AP. Your teacher definitely asked that, guys. 109.5 degree angle. So every angle here, the adjacent angle, guys, is what? They all have the same angle, 109.5 degree angle. Okay, that's a tetrahedral shape. So keep in mind, guys, whenever you see sp3 hybridization, I mean, it's very simple, right? If the steric number is 4 things surround, okay? Then what happens? Oh yeah, sp3, it's what? Tetrahedral for AP level, okay? Very simple stuff, nothing fancy, okay? Let's take a look at this, okay? It's the same thing, okay? 1, 2, 3. Keep in mind, listen carefully, okay? The lone pair of electron also gets counted into the steric number counting, okay? This one counts in as well, okay? Which means the steric number is 1, 2, 3, 4. You understand, guys? It's also what, guys? sp3. This one is also what? Nitrogen has a hybridization of what? sp3 also as well, okay? This one is sp3, that's sp3 as well, okay? But now, what's the difference, guys? Is what? One of them is what? A lone pair, okay? sp3, one lone pair. So if you look at it, guys, the shape perspective, guys, nitrogen here. This is what it looks like, and lone pair. So all the difference is what, guys? They're exactly the same, except for what, guys? This one is gone when what replaced with the lone pair electrons. That's the only difference here. You understand? Now, what do you call this, guys? If it's an sp3, central atom hybridization, but one of them is what, guys? One of them is electron. What do we call this, guys? It's called what? Trigonal pyramid. Okay. If you're using your phone, I'm gonna take it away. Put it away, please. So it's called a trigonal pyramid. Okay, that's what we call it, guys. Okay? NH3. So keep in mind, guys, 3 of these and one lone pair. Okay, keep that in mind, guys. So whenever you see sp3 with one lone pair, what happens, guys? You know, it's a trigonal pyramid, right? And also, guys, okay. So this is something they ask you, right? The bond angle. If AP asks you for the bond angle, okay, you can say 109.5 as well. You can say that. They're not gonna mark it wrong. But you gotta be a little careful with your school teacher, guys, by the way. So because of this electron lone pair, they can push. So keep in mind, these are what, guys? There's a bond. Bond is what, guys? Electrons, right? So they're gonna push it down a little bit. the bond angle gets a little bit smaller. The bond angle gets a little bit smaller than 109.5 degree angle. But on the AP, if you put 109.5 angle, they're gonna ask you, oh yeah, give me the bond angle for this. If you put 109.5 degree angle, that's fine. They're okay with this, okay? I'm not kidding, okay? So same thing for this one as well. I mean, so same thing, guys. This is also what? Stirrup number 4, 1, 2, 3, 4, right? Which is what? This is also SP3. Okay, so now that's water. And you gotta understand, guys, okay? Water. So I forgot what year. One of the students asked me, okay, if you draw a water molecule, why can't you draw like this and become linear? Like, do you see that, guys? Like, so whenever people draw water, like they draw like this, right? Anyone draws like this. No one draws like that. Okay? They draw like this, right? Water. Oh yeah, water molecules. What? They always draw bent. Okay? And when I draw like this, one of the students asked me, why is it not linear? That's a very good question. That's a very nice question, right? So why can't you draw this linear? And we know, oh yeah, the shape is bent. Why do you draw like this? Why not like this? That's a very valid question, by the way. Okay? Because what? Water molecule is what, guys? It has steric number of 4, which is what? It's sp3 hybridization of the bond angle 109.5 degree angle. So, which means, guys, this one is also what? The backbone shape is what? Tetrahedral. Do you see that, guys? So meaning, guys, just how the shape was. This is a shape, right? That's basically sp3. Okay? Do you see that, guys? So if you remove one, that's this guy. If you remove the other guy, that's water. That's bent shape, you understand? Because what? Their backbone is sp3, okay? So if you look at the shape, guys, oxygen here, the lone pair, and what? This is the hydrogen sticking out, there's hydrogen going back. That's the water shape, okay? The bond angle is. You can still say, this is what, guys? 109.5. Or you can say a little bit smaller, that's fine, okay? But you gotta understand, guys, okay? So whenever you see sp3, the bond angle stays like this, and what? The backbone shape is tetrahedral, depending upon what? How many lone pair electrons you have. It could be what? It could be trigonal pyramid, or it could be what? A bent shape, okay, depending upon the lone pair electrons. Very, very important, guys. Okay? So guys, some of the stuff that we drew. So, okay, let me tell you guys, okay? So, we already did this, drawing the lowest dot, so I'm not going to repeat it, guys. Maybe repeat this. So, some of the stuff we drew, guys, CO2, okay? And let's talk about SO2. Let's talk about SO3. So we drew this, guys. Okay? So probably last week, guys. I'm not going to make you do this drawing again. Let's just talk about it. So CO2, right? So carbon dioxide, carbon in the middle, double bond with the oxygen. We talked about this, okay? And now SO2, sulfur. So even like the what do you call it, resonance, I'm not really interested in that right now. and this one, sulfur trioxide, that's what it looks like. So let's think about, guys, let's figure out, guys, their hybridization and their shape, okay? So let's take a look at carbon, okay? So carbon central atom surrounded by what? Two of these guys, okay? So if you look at this one is a little tricky. I mean, I don't know. Some students really struggle with this, by the way. So carbon is in the middle, okay? So typically the middle, the hybridization of the central atom will decide the shape, right? So the steric number is what? Steric number is 1, 2. Okay, there are two things surrounding. So keep in mind, guys, double bond does not matter. Doesn't matter, double trip doesn't matter, okay? So what's the hybridization, guys, central atom? S1P1, okay? Sometimes they call this sp hybridization, okay? When you have sp, what happens, guys? This is what? This should be what? Linear. Whenever you have sp, they're what? Linear. You understand what I'm saying? So keep in mind, guys, so sp3 was what? Tetrahedral. Sp is what, guys? Linear, just like CO2. There's no lone pair, linear, okay? So I'll explain double bond a little later, guys. You have to know the double bond, guys, where they come from. How about these guys? What do you think? So you have a 1, 2, and 3. Guys, third number is 3, which is what this must be. sp2. This is also what? 1, 2, 3, sp2. Same as sp2, right? So if it's sp2, what happens, guys? This one is what? Trigonal planar. Okay. So keep in mind this bond angle is what? I mean, it's obvious, 180, right? Trigonal planar. So planar shape is what, guys? It's a flat shape on a plane. Okay. So the bond angle is what? Bond angle must be 120. 120, 120, 120. Okay. That's trigonal planar. And this one is SP2 as well. So 1, 2, 3, right? Story number 3, 1 SP2. So which means what? This one is a lone pair. All right, lone pair, guys. What do you think? This is what? This is also. This becomes what? A bent shape. Okay. So it's SP2, but it's got a one lone pair. What happens, guys? This becomes what? A bent shape because there's nothing here. Okay. But compared to the water molecule H2O, this is what, guys? The bond angle is what? Different. This is 120-degree angle. Compared to water molecule, which is what? Water molecule is 109.5-degree angle. So keep in mind, guys, if it's an SP3, okay, tetrahedral, trigonal pyramidal, or it could be bent. Depends on the lone pairs. It's SP2, trigonal planar, flat shape, or what? Bent. It's SP, S1, P1, it's what, guys? It's gonna be linear. Very simple, right? It's like, dude, it's nothing fancy, okay? And the bond angles, okay, you got all the bond angles, right? So, before I move on to the other hybridization, guys, I want to talk about double bond, triple bonds. Okay, so AP will ask you guys the origin of the double and triple bonds. They'll ask that question. So let's talk about it. The best way to explain this, guys, you gotta pay attention to this, guys. So let's draw C2H4. This is called ethene, okay? Let's draw this. So I'm gonna draw it, guys, I don't want to waste my time. So this is ethene. Okay? Right there. So let's take a look at this, okay? Carbons, let's think about it, okay? What's the hybridization of the carbon? So carbon is what? This carbon is what? 1, 2, 3, which is what? SP2, right? This one is what, guys? Also 1, 2, 3, SP2. You understand, guys? So they're both SP2s here. Okay. So now I'm gonna just draw the orbitals, guys, SP2. So carbon looks like this. Carbon looks like this. Looks like this. Looks like this. Okay. So now hydrogen is what? Hydrogen is what, guys? S only, right? So if you look at it, guys, what happens, guys? This bond, the bond between the carbon. If the question asks you guys, okay, what's the bond between the carbon and hydrogen? Is what? S of the hydrogen, what, guys? SP2 of the carbon. That's the covalent bond between the carbon and hydrogen. You understand, guys? So that's basically what this bond is. And you gotta do the same thing for this carbon. Is what? Like if you draw this guy, that's what it looks like. And also what, guys? Yeah, hydrogen here. Same thing. Same thing. This is also what? S and SP2. So now it comes down to the two carbons. Do you see that, guys? Orbital. This is orbital overlapping. So it's what? This one has two bonds, right? Two bonds, which is what? So keep in mind, guys, again, listen very carefully. You have a single bond, double bond, and triple bond. That's all you got, okay? If you have a single bond, it's what? It's got one sigma bond. Double is what? 1 sigma, 1 pi. Triple is what, guys? 1 sigma, 2 pi. You understand, guys? So now, look at this, okay? This one is what? SP2 to SP2 overlapping. Okay, this orbital overlapping you see, guys. Okay, that will give you what, guys? This will be the sigma bond. Do you understand, guys? The sigma bond of the carbon to carbon is what, guys? SP2 to SP2 overlapping. But you gotta ask yourself, what about the pi bond? Where does that come from? That is the question that's on the AP. Okay, the question on the AP is, what is the nature of the double bond? Where did it come from? I mean, I don't see it right now. Okay, so I only see what SP2, SP2 overlapping, which will give them sigma bond. Okay, you don't have to really know what sigma means. Okay, it's basically what? The orbitals longitudinally overlapping. Okay, that's called a sigma bond. But what about the pi bond? You gotta ask yourself, where did that come from? Okay, so now let's go back. Okay, that's the carbon atom. So carbon atom right now has what? S1P1 right now. Okay, what does it mean, guys? there was one s orbital and two p orbital has been involved in the what? Hybridization. So meaning, guys, carbon has what, guys? Carbon has 1, 2s and what? 3 p's. Px, py, pz. Okay? So what does it mean by sp2? 1s, 2p has been hybridized. Do you understand what I'm saying? What about this guy? This guy disappeared? This guy gone? What do you think, guys? No, it's still there. So whenever we say sp2 means what, guys? sp2 means only one s and two p orbital has been hybridized, and what? They created this. You know what I'm saying? But now, what about the p orbital that hasn't been hybridized? So that p electron and the pz, that is what will create the pi bond. Okay, so meaning, guys, right now, the carbon, it has what, guys? The unhybridized p orbital, both of them. And that will, these guys will overlap, which is a pz, they're in the same axis, pz, and what? And create the pi bond. That's what pi bond is. So if someone asks you, okay, so where did the pi bond come from? If that's a question on the AP, okay, or your school teacher, whatever, okay, if you're good enough to answer the questions, it'll be what, guys? Your answer should be unhybridized electron, the p orbital, overlapping with the adjacent p orbital creates a pi bond. That'll be the answer, guys. You know, I mean, if you understood it, great. If not, it is what it is right now. It's summer, guys. So, I mean, it's good to know. I mean, like, it's something you have to know anyways. Just, you know, but just so you know, that's what it comes down to. Okay, pi bond is what, guys? When electron in the p orbital hasn't been hybridized, they can overlap in what? With the adjacent p orbital and what? Create a pi bond. So let's take a look at, guys, C2H2. Look at this. So if you draw this, it's what? Triple bond. That's what it looks like. You see that, guys? I mean, it becomes more obvious now, right? If you look at this, what happens, guys? Carbon is what? This carbon is what? sp hybridized, right? This one is what, guys? Also, this carbon is also sp hybridized, right? So sp is what? Linear. This is linear. If you look at it, guys, right now. So if you look at it, guys, the hydrogen is here, hydrogen is over there. So this bond is what, guys? sp of the carbon, s of the hydrogen. That's what this single bond is, okay? And now they're triple bond. So one sigma is what, guys? sp of the carbon to sp of the carbon. Okay, that's one sigma bond, right? And where did they get the two double bond from? Where's this guy? Where's that guy from? Or this guy from, right? That's a double bond, right? It's what? Because carbon is what, guys? sp hybridized. You understand, guys? So again, going back to the orbitals for the carbon, which means what, guys? I mean, so like I'm not gonna draw the whole thing again, guys. They use what? 1s and 1p, because it's what? sp hybridized. They have two p orbital that hasn't been hybridized. Okay, so one at the y-axis and then one at the what, like z-axis. So they're gonna overlap and what? Create what? Two pi bonds. Okay, so again, because they have two unhybridized p orbital electrons, they will overlap and what? Produce a pi bond, two pi bonds. And that is the origin of the pi bonds. Okay, which they will ask you. They're not gonna ask you to draw it. They're not gonna ask you to define this. All you have to do is ask is what? They're gonna ask you, where did it come from? Okay, your answer is unhybridized p orbitals overlapping. That's your answer, okay? And that's AP. I'm not making this up, guys, okay? I will not teach you guys like anything that's above the AP level, guys. If I do, I'll let you know. This is not something you have to know. So, like, you know, I'm talking about that, guys, okay? AP does this, okay? The AP, like College Board guys, they do this. Meaning, the hybridization, okay, does it apply for all the molecules? That's a question you have to ask yourself. This is strictly between us, okay? This doesn't apply for your school right now. Maybe your school teacher is good enough. I don't know, you know? But who knows? But now, so let's take a look at, guys. So let's take a look at, guys. Okay, if you draw NCl3, okay, draw, you know, NCl3, right? You draw like this, right? Nitrogen in the middle, Cl will surround it, single bonds. That's what you draw. You know, so basically, I mean, again, it's basically what, guys? This nitrogen will be what, guys? sp3 hybridization, right? We talked about this, right? There is a little controversy with this also as well, guys. I'm not gonna go there for you guys. So, but what about it turns into P? PCl3. PCl3, guys. So now P phosphorus, guys, is right underneath nitrogen, okay, in the periodic table. They have the same number of valence electrons, the same shape. So, yeah, just between you and me, okay, I'm recording, guys, okay, so, which means, like, you know, like, this is something that you can kind of go back and like, look at it yourself. Yeah. Would P also have sp3 hybridization, guys? Do you think that's gonna happen, guys? What do you think? They really don't. P, guys, like phosphorus, they really don't hybridize, okay? But College Board, like listen to me, listen carefully, okay? College Board, if this is a College Board question on the AP, if they ask you what is the shape and hybridization, it's sp3. You gotta like, so what I'm saying is, guys, again, truly, guys, past the second principal energy level, which is like nitrogen, oxygen, like, you know, fluorine, stuff like that, past that point, they really do not hybridize. So, you know, they really don't like S and P, sp2, they don't do that, okay? But, you know, like College Board, if they give you this, it's still hybridizing to sp3, okay? That's College Board. So even you're past the second, this is the third principal energy level, they still hybridize. That's one of the things that I don't like they do that, guys, by the way. But if you go to college and like higher chem, guys, they might not do this on college, by the way. Because, you know, this is I don't think it's wrong. It's hard to say, okay? So, you know, yeah. So I'm not gonna go any further than this, by the way, with you guys. So they really, so when they have PCl3, their shape is not really this, okay? Like what I'm saying is, yeah. So I'm not gonna go any further, okay? So, you know. But that's a limitation of AP, okay? If you wanna learn further, guys, you gotta go to like Olympiad or like higher chem to understand what the hell's happening. The shape of this, guys, is like this. I'm not. They're more like they're turning to PCl4. Whatever, okay. All right, so. All right, so now there are two additional hybridization that you guys have to know. And that's it. And then we have to discuss the IMF, intermolecular forces, which is very simple for you guys. And then we're going to go to gases, okay, as time allows. So let's take a look at this, guys. Listen carefully, okay? This is an example that College Board uses a lot, guys. PCl5. PCl5. Okay? So when you see this, there's something wrong with this. Like you gotta spot it. Like there's something obviously wrong with this molecule right now. Okay? So we've seen this during the drawing, guys, by the way. But if you look at this, what happens, guys? Phosphorus in the middle, Cl surrounds it. Yeah, what do you think is something wrong with this right now? This is a shape, by the way. That's a shape. What is wrong? Yeah, what the hell is wrong with this? Phosphorus made what? 1, 2, 3, 4, 5 bonds. Phosphorus made 5 bonds here. Which means what? This is what? Going against the what? Octet rule. Octet rule, out the door. So we had a similar thing like this for what? Drawing the SO4 sulfate. We had a similar thing like that, okay? It doesn't obey the octet rule, okay? So is that something that they can do? Is it possible to draw like this? Absolutely yes, okay? Because why? Phosphorus, again, is what, guys? On a third principal energy level. Which means what, guys? Not only they have what? S and P, they got what? D block. Which means what? They can have up to 18 electrons overall. Okay, so they don't. So once they're past the second principal energy level, it's what? Octet rule is garbage can. Okay, they don't need anything. So now you gotta be careful. Okay, can you have this then? Can you have NCl5? That's an AP question right there. Can you have this? Can you have a nitrogen here, guys? Instead, can you have it? No, you cannot, because why? Nitrogen is what, guys? On the second principal energy level, they do not have the D block, which means what? The max is what? 8. Okay? So that is not, so P, when you see this, you should know on the AP Chem, that's what? That is not a possible molecule. Because what? Nitrogen is what? Tied to only 8 electrons overall. So if you have stuff like this, what do you think, guys? So this is a very common mistake to make. So I asked the students, guys, what will be, so lone pair electrons, guys, don't forget that, by the way. So the question I'll be asking, guys, what will be the hybridization of central atom? So it's hard to say hybridization again because phosphorus, guys, they don't really hybridize, whatever, you know, for the AP. What do you think, guys? So steric number, right? 1, 2, 3, 4, 5, right? What happened? So this is a very common mistake. They say, they what? They say this. Wrong. That's not, so why is that possible, guys? You what did? Why not? Phosphorus, they don't have 4 orbitals. Okay, it's not possible. You understand? Phosphorus has what, guys? Only 3 orbitals. That's not possible. They have only 3. And I mentioned it, right? They involve what? D orbital. Okay, which means what? Turns into what? 1, 2, 3, 4, 5. D1. S1P3D1. Okay, that's their hybridization. So this is the question I get. Okay, sometimes the textbook says the DSP3. Okay, sometimes they give it like this. Doesn't matter. It does not. The order does not matter. But your school teacher might say, oh yeah, if you write it like this, it's wrong. Whatever, follow the teacher's way, guys. But you can write it like this. You can write D1 S1. You can say S1 P3 D1. That's fine. Okay, for the AP. All right. That is hybridization, guys. And the shape of this, you gotta notice for the AP, guys. Shape is what, guys? Trigonal bipyramid. Okay, this shape is trigonal bipyramid. You gotta know this, okay? So you know. So take a look at this, guys. Yeah, listen carefully, okay? I mean, it's good to know. I mean, I don't know if you can memorize it, guys, before the school starts, but at least you know, when you go to school, guys, I mean, you know it when you go in, okay? Trigonal bipyramid, which is SP or DSP3, whichever you call this, okay? This hybridization, guys, okay? There's an axial line running 180-degree angle, straight line, okay? There's what, guys? Also, these are on the same plane. Like trigonal planar, right? These are like trigonal planar, bond angle 120-degree angle. This is what? A straight line 180, okay? So it's like plane level and what? Axial level, okay? That's why they call this as what? Trigonal bipyramid. Because what? It looks like a pyramid, right? This looks like a pyramid. So let's call this what? Trigonal bipyramid, that's DSP3. And the bond angle is what, guys? 120, okay? And 90. Okay, 90 here, 90 degree here. Okay. Sometimes they say like 180, like 90, 120, like 180. I mean, whatever. It depends on the school teacher, okay? So that is not a problem, guys. Like, this is really not a problem, guys. The problem is like the other shape. So what if, guys, like one of them becomes a lone pair? So let me kind of make it like easy for you guys. So A is central atom, X is what surrounds, okay? AX5. It's what? Trigonal bipyramid, okay? That's what AX5 is, right? What if it is AX4, E1? E1 means what? Lone pair electron. So one is a lone pair. So this, for example, guys, becomes a lone pair. Okay? Still, it's what, guys? Like at DSP3, right? But it's just what? Turns into a lone pair. One is a lone pair. Okay, just like what? Bent's shape, right? What is the shape of this? They'll ask you the shape. What is the shape, guys? This, yeah, dude, I'm not kidding, guys. You guys, the shape is called seesaw shape. It's called seesaw. Do you see this, guys? That's where like they get on, right? This is what? The fulcrum, okay? Like a seesaw, like. So that's what they call a seesaw shape, guys. So one of them becomes a lone pair, a seesaw shape. And now, if it's AX3, E2, so now one more becomes a lone pair. Okay, so two lone pairs. So there's one running straight down. There's one over there. What do we call this, guys? This is called T-shape. Okay. This is like SAT or the lower chem guys. They never asked this, but you have to go with this for the AP. If one more becomes a lone pair, this becomes a linear. So now it becomes a AX4. AX2. E3. This is what, guys? It becomes linear. So you gotta be careful, guys. Okay? When you guys have a DSP3 shape, right? It becomes what, guys? Trigonal bipyramid. It could be seesaw, T-shape, or linear based on what? Based on how many lone pair elections you got. So this is something that you guys have to know for the AP. They will ask this question on the AP as well for the drawing structure. Any questions, guys? So memorization, right? Like it will not be as bad as bio, but still, like you have something to memorize. It's not that bad. All right. All right. So the other one, guys, I can't think of an example right now, but there's one more that you have to know in terms of hybridization, guys, and that is D2sp3. So that's one more hybridization you have to know. Okay. So central atom A and X surrounding. So similar. Okay, I understand here. There is an axial line running from top to bottom. Okay, from top to bottom, guys, it's running axial line, similar to the trigonal planar, trigonal bipyramid, guys. And here's what. Like, you know, four of them on the plane level. So this is called octahedral. Okay? It's called octahedral, okay? And now, as you can see, guys, 1, 2, 3, 4, 5, 6, okay? Sturdy number 6, if you add these up, guys, it becomes what? 6 here, okay? That's an octahedral shape. So now, it's good. It's something that you have to know for the AP as well, guys. I can't just like not do this. So what happens is, they barely ask this question, by the way, but now if one becomes, if it's AX6 octahedral, guys, AX5 E1, okay, so now one lone pair. It becomes one lone pair. What happens, guys? It's called square pyramid, okay? So it's square base on the top here, okay? It's called a square pyramid. Okay, that's the shape, square pyramid. If 2 becomes a lone pair, yeah, what does it become, guys? This becomes, so it's AX4 E2. This is what, guys? Square planar. And this is it. That's all you have to know now, okay? It's called square planar. So if you have a D2sp3, okay, you be what? Octahedral, one lone pair becomes what, guys? Square pyramid, 2 lone pairs, square planar. You gotta know what it is, okay? And that's it. They're not gonna go any more than this in terms of shape perspective. That's AP. AP stops here. Okay? So what will AP ask you guys? Okay, so like in terms of hybridization, guys, how they're gonna ask a question, guys, is something like this. So they can't, like, dude, like I tell you, they'll ask you this. Like, some of you guys already know what the shape of these guys will be. Okay, they'll give you this. Okay, so this is what, you don't have to really know what it is. Okay, so you know, this is called acetic acid. Acetic acid. They're not gonna ask you what the name is. This. I mean, AP guys, they move away from like asking guys like the shape of this and memorizing that. They don't ask that question anymore. You gotta understand, guys. When back in time, when I'm taking the AP back in time, like when I was in high school, dude, I tell you, it was very much like memorization, guys. For example, they asked you, oh, if you add like A and B, what's a product? I'm not kidding, guys. You gotta go back and look at early 2000 questions, okay? Like they look at, if you add a baking powder with the acetic acid, what's a product? Like they ask those questions, okay? Not anymore. They don't care about the name, they don't care about anything, guys. Question is asking this on AP nowadays, guys. They're asking for, determine the hybridization of this carbon and this carbon. That's what they're asking. What's the hybridization of this carbon, C1 and C2? What about this one, guys? What do you think, guys? This is sp3. Guess what? 1, 2, 3, 4. Starting number is 4. What about this one, guys? What do you think? We got 1, 2, 3, which is what? sp2. That's what they're asking. It sounds very simple. Oh, dude, like that's it. But kids get it wrong. As students get it wrong, I'm not kidding. Okay, so they're not asking for the structure. They're not asking for the shape. They can, but like they give you the structure of it. Find me the hybridization of this carbon next. That's what they ask you. I mean, this is hard, guys. I don't think so. They don't ask you, you know, like, oh yeah, like, what about this guy? They don't ask this question, okay? So, on that note, guys, let's talk about why, like, they don't really go too deep into this. So let's talk about it, okay? So, this is not something that you might have to know for the AP, but let's talk about this a little bit, okay? So there has been some issue with what I'm going to tell you, okay? Because not an issue, but discrepancies, okay? So let me tell you guys. What about this? When you draw NCl5, NCl3, I'm sorry, NCl3, or even like two, like CF3, CF4, I'm sorry, CF4, whatever, okay? So when you draw like any one of these guys, okay, there's a little issue here. Because when I draw this, right, CF4, this is what you get. Okay? So I'm going to focus on this bond right here. Okay? So, yeah, based on our understanding, carbon is what, guys? Carbon must be, yeah, hydrogen is what, guys? sp3, no question, right? sp3. But, yeah, so the question we'll be asking, okay, I mean, so if your school teacher does this, okay, when you go to school, you gotta rely on teacher, okay? You gotta go follow her method, okay? Because it could be one or the other. They're gonna ask you, okay, which orbital overlaps for this bond? That's what they ask you. What orbital overlaps here? That's what they ask you. So keep in mind, okay? Like some textbook says the fluorine also hybridized, okay, into what? sp3. You understand, guys? Which means this is what? This bond is sp3 of the fluorine, sp3 of the carbon. Okay? I'm not kidding, guys. That's what they say. Some textbook says this, which means what? This also hybridized. Some textbook says, no. If the fluorine does not get hybridized, okay, and what happens, guys? It's only the unfilled p orbital gets hybridized, gets what? You know, shares electron and what? Becomes p and sp3 of the carbon. So, one or the other, okay? If again, AP will never ask this question, by the way, okay? AP, like, they know this is a problem. They used to ask this question on the old APs and also old SAT questions as well, okay? And textbook has a different understanding and also explanation. It could be this, or it could be sp2. You know, for fluorine, that is something, you know, like, so if I were the teacher, guys, your school teacher, guys, I would not bring it up, you know, based on this. But central atom is also sp3. The shape will be tetrahedral, but the bond overlapping, either the sp3, or p and sp3. So that is something that, guys, depends on the school teacher, okay? So I'm not going to refer to this. Any questions, let me know. Any questions, concerns? Let me know. Okay. So now, guys, okay, like this is now, guys, very, very important stuff we have to discuss now. So you guys know the Lewis dots, and we discussed how to do Lewis dots. We discussed how to the shape of the molecules and stuff like that. So what you guys have to know now is being able to determine the polarity of the molecule. Polarity. So meaning there's what, guys? There's a polar molecule, there's non-polar molecules. Okay, so when you do the Lewis dots, know the shapes and all, would it be a polar molecule or non-polar molecule? Okay, that's one of the things you have to understand, guys, okay? So what determines polarity of the molecule? So it becomes a non-polar molecule, there's a polar molecule. So what determines this is what? Basically what, guys? The electron distribution for the molecule as a whole. Okay? So it becomes a nonpolar molecule when what, guys? There is a symmetrical distribution of the electrons within the molecule. So keep in mind, okay? I'm not looking at the bond's polarity, okay? The bond is what, guys? It's only like 2 electrons, okay? We're looking at what, guys? The overall electrons in overall the molecule overall, okay? The entire thing. So now, you gotta understand, guys, here, so let's take a look. So this is what I mean by this, okay? When I draw Cl2, okay, when you draw Cl2, guys, what do you draw? Cl and Cl, single bond, right? That's what it looks like. So I understand, guys, okay, Cl and Cl, keep in mind, this bond is what, guys? It's a non-polar bond, okay? Keep in mind, guys, when do you call a bond non-polar? When what? They have the same electronegativity, okay? So, like, for your AP perspective, okay, when you have a non-polar covalent bond, okay, that is when what, guys? Typically, every time between what same elements, Cl and Cl, fluorine to a fluorine, carbon to a carbon, that's a non-polar bond, okay? If an element is bonded to a different element, covalent, that's what? That is a non-polar covalent bond, because why? They have, or they should have, different what? Electronegativities, okay? So if you are bonded to a same atom, same element, it's what, guys? That is non-polar covalent bond. That is a polar covalent bond. It's a given, okay? You don't have to memorize a table for this, guys. Nothing like that, okay? The bond is actually what, guys? Bond is non-polar bond. But what about the entire electron for the whole thing? Dude, carbons, Cl is what, guys? Like 17 electrons overall, guys? So what do you think about those? So because they have what? Equal electronegativity, what happens, guys? Electrons on this side and that side should be what? The same. Okay, that means what, guys? If you have like electrons here, like 10 here, you can find 10 there, okay? Which is what? Symmetrical distribution of electron overall for the molecule, which we call as what, guys? Non-polar molecule, okay? What about like polar then? So now what about this? HCl. HCl, guys. If you look at it, guys, chlorine has a greater electronegativity and they have more electrons. So if you look at it, guys, that's what it looks like. Okay? Think about it, guys. HCl, it doesn't have any charge at all. There's no charge for HCl. Number of protons, electrons are the same. But the distribution of electron is different. Cl is what? More electronegative. Because if it pulls electron to itself, there's more there. What happens, guys? This will be more partially negative, partially positive. Okay, there is a polarity within the molecule. That is what we call, guys, what? A polar molecule. Okay? So, determining the polarity of the molecule, my recommendation is you might want to draw the molecule overall. Okay? So it's hard to say, unless you really know the shape, guys, it's hard to say whether it's polar or non-polar based on the formula. You got to draw this out. Okay? So for example, the stuff that we drew before, what about like stuff like we drew, guys? So it's like CF4. What this guy? Carbon here, fluorine. We can't really draw like this in a flat shape, but tetrahedral shape. Okay. Let's take a look at this, guys. If you look at this, fluorine is more electronegative. Okay, which means what, guys? Fluorine pulls electron to themselves, but it's what? All 4 sides. You see that, guys? But overall, what happens, guys? Because of the shape of the molecule, so that's what the AP college will ask you, okay? This one has what? 4 non-polar covalent bonds, like this. Okay, but why is it it's a polar bond, right? Polar bonds, okay? Because they're different elements. But why is this molecule non-polar molecule? That's what they're gonna ask you. Okay, what do you think, guys? Because what? Fluorine will pull the electron to itself, okay? But due to what? They say symmetry of the molecule. Okay? It pulls it to itself, it pulls it to itself, what? Polarity cancels out. That's a term they like to use, guys. The polarity cancels out on both sides. And what happens, guys? Overall molecule becomes what, guys? A non-polar molecule. So you have to determine symmetry, okay, and polarity cancels out. Okay, so there's what? Zero dipole moment. Okay, because what? Zero dipole moment is what, guys? They will cancel out. And what happens, guys? Becomes what? A nonpolar molecule. So very important to understand, guys, here, because they will ask you to explain this. Why is it nonpolar? It sounds very simple, but I don't know. And one thing to know for you guys, okay, if a central atom. So one thing to know, guys, typically, right, if central atom has a lone pair, 99% of the time, this is a polar molecule, asymmetrical, okay? This is a polar molecule. So when you draw the Lewis dot, right, if this guy has a lone pair central atom, guys, what happens? This is what? You know, like it's a polar. That's one of the ways to kind of look at it, okay? Polar molecule, no question, guys, okay? So again, in order to be nonpolar, is what, guys? The electron distribution must be symmetrical like this guy, okay? There's like going here, there's one here, there's one there, they cancel out, okay? But stuff like this, guys, there's lone pair of electrons, guys, this becomes partial negative, guys, which means what? This must be a polar molecule. That is something you have to know. It's very important to understand this because what? Based on this, you have to determine their what? Intermolecular forces, okay? Same thing, guys, yeah? When you show SO2, what this guy? What do you think? Polarity of this guy, what do you think? Again, lone pair electron, what happens, guys? This will be what, guys? This will be a polar molecule. Okay, lone pair electrons right there. So, and also, but what about SO3? How about this? So, unless, like, dude, like, unless you're like super good, I don't know, like, you gotta draw the molecule. Okay, what about this one? What do you think? Oxygen pulls electron to itself, all three sides equally. 120, 120, 120. What happens, guys? This will be what, guys? Because due to symmetry, what happens, guys? This will be what? A non-polar molecule. I tell you, this is very important to understand, guys. You gotta really get this. Okay? Non-polar molecule for this guy, and what? Polar molecule for this guy. Okay? Understanding what we're doing. Okay? So I'm gonna give you some molecules and you determine whether some of them is polar or non-polar. And show the structure for you guys. I mean, like, determine this polarity, guys, based on what I'm giving you right now. Let's do easy ones first. So, very good one.
Wait, is there a reason why you box here too?
Yeah, this AS is a lot as well. Yeah. So guys, try to figure out their polarity, guys. Non-polar, polar, non-polar. I mean, some of the stuff we already talked about, but I recommend you to draw some of the molecules. I mean, we already drew this, but you still draw them, guys. Determine their polarity. Okay? So if you draw the molecule, guys, what happens, guys? Carbon is actually more electronegative. Okay. So between the bonds, guys, what happens? Carbon is actually what? Like more electronegative. It pulls electrons to itself, but because of the fact that what, guys? The symmetry of the molecule, they cancel out, and what happens is non-polar molecule. This is non-polar. Okay. NH3. You draw this. What happens, guys? The lone pair of electrons. Okay. What happens, guys? This is polar. They asked this one a lot. They asked this on the EP, guys, many times. Okay. Carbon in the middle, oxygen surrounds it, double bond. Okay, so you have to understand, guys, the oxygen, it pulls electron from the carbon on both sides. Okay, so if you look at this, guys, basically you have to understand, so this is what, guys, this creates, there is a polarity between the carbon and oxygen themselves. But because you have to understand, like the symmetry of the molecule, okay, the polarity cancels out. Okay, so pull from one side, cancel that side, it cancels out. And what happens, guys? There becomes what? Dipole moment becomes 0, okay? Because they cancel out, which means what, guys? This becomes a nonpolar molecule. They asked us a lot on the AP, okay? You gotta explain, like how to explain it, okay? I mean, dude, like, right now, like, you're not taking the AP until, like, you know, in about a year. But one of the questions they ask a lot of times, okay? BH3, okay? So this one is a little unique, guys, by the way, okay? Boron, so the shape is this. So boron is one of the exception to the octet rule, okay? The boron is okay with what? Not having the octet. Because why? We talked about it, guys. Octet gets superseded by what? The formal charges, okay? So boron, like if you look at this, the boron's formal charge is 0. Do you know what I'm saying, guys, here? Okay? Because what? Boron has what? 3 valence electron, minus 3 bonds, okay? No lone pair, 0. So 0 is a formal charge for the boron right now. They're happy, okay? They don't have to have the octet. We talked about this, right? Formal charge last week, right? So, which means what, guys? Yeah, so it's a trigonal planar. Boron might be more electronegative. What happens, guys? It cancels out, okay? Due to the symmetry of the molecule, and what happens, guys? Because what? It becomes a nonpolar molecule. So this becomes what, guys? This becomes, what do you think, guys? Trigonal planar shape, guys, sp2. What happens, guys? This becomes what? Nonpolar molecule. So this is nonpolar, nonpolar, okay, nonpolar, this is polar, O3. So if you look at O3, guys, if you're smart enough, you have to understand, guys, this will be the same shape as what, guys? SO2, okay? Ozone layer, oxygen in the middle. So a total of 18 electrons overall. That's what it looks like, guys. It's ozone layer. You see that, guys? So we talked about it, guys. If there is a lone pair of electron, what happens, guys? This becomes what? This becomes a polar molecule. Okay. PCl5. If you look at this, so if you look at this, guys, polarity-wise, the CLs, they will cancel out. These guys are planar. What happens, guys? They will cancel out also as well. Because what, guys? Nonpolar molecule. Symmetrical molecule, guys, nonpolar. So nonpolar, polar, nonpolar, nonpolar, polar, nonpolar, okay? But this one, guys, you might have to know a little more because if it becomes a lone pair, what happens? This is polar, okay? So this is a unique case, right? If this one's lone pair, what happens, guys? This is a T shape again. This is what? This is a polar, okay? What about now? This one, 3 lone pairs, linear. What do you think, guys? This is actually nonpolar. Okay, so you know this is nonpolar. So this is the unique case where this becomes a nonpolar molecule. Okay, so with 3 other lone pairs on the same axis, okay, not same axis, on the same plane, on different axes, this becomes what, guys? This is nonpolar. So this is where I think only the unique case where you can have a lone pair on the central atom and becomes nonpolar. Okay, and I think the square planar also can be that case as well. But I don't think College Board will ask this question. College Board will not ask this question, by the way. Your school teacher might, you know, but the College Board will not. So determining the polarity, it's very important, guys, to understand, just so you know. The reason is, this is the reason is, we have to why. So let's discuss, guys, the intermolecular force now, okay? I think this will be the last portion that we have to discuss for this today's class. So this is very, very important, guys, IMF, intermolecular force attractions. So IMF, guys, like inter, between, right? Molecular forces, force between molecules, okay? So keep in mind, guys, every attraction between the molecules, what, guys? Every attraction in chemistry is between what? Between plus charge and minus charge. That's the attraction between the two charges. Everything, any attraction in chem is what? Plus charge and minus charges, okay? And now, it's very simple for a polar molecule, right? For example, guys, okay? If you draw NH3, okay? the polarity goes like this way, okay? This is partially negative. This is a direction of electron, okay? Positive charge, positive and negative. You see that, guys? Polar molecule, okay? You understand, guys? This is negative charge, positive charge, partially. So do you see this, guys? It's a lowercase delta, okay? Partial. This, which means what? It's not a permanent minus, it's not a permanent positive. But keep in mind, listen carefully, okay? When you have stuff like this, SO4 2 minus, okay? Yeah, what do we call this, guys? What we call this what? Polyatomic ions. You understand, guys? When you draw this guy, remember we drew stuff like this last week? This is what, guys? This is a polyatomic ions. Yeah, this is not like polar, non-polar. Okay, this is what? This is an ion by themselves. This is an ion like Na plus. So you cannot say, this is non-polar symmetric. You can't say that because what? They already got a minus charge. Okay, you have to exclude that from this question of polarity here. We understand they're molecules, but no, they don't have a partial charges. They have a permanent charge. Okay, so this is out of the discussion right now. But if you look at this, so partial negative, partial positive, they're partial. They're not fully negative here, okay? So, dude, think about it, guys. Okay? If there is one more molecule like this, partial positive and negative, what happens, guys? There's attraction, okay? That's attraction right there. That is what? Attraction between the molecule. What do you call this, guys? IMF. Okay? So polar molecule attracts polar molecule. Okay, what do we call this, guys? The name of this IMF is called dipole-dipole interaction. You can just call it dipole-dipole. Okay? Dipole means what, guys? It's got two poles, positive and negative. Okay, negative and positive here, okay? Dipole-dipole interaction. So, I mean, dude, obviously what happens, guys? Polar molecules have a dipole-dipole interaction. Because why? They have a partial negative positive. No question about that one. And now something like this. So this is, you gotta understand, okay? Yeah. Stuff like this, some of them have an abnormal strong dipole-dipole interaction. Abnormally strong. So, dude, how do you make dipole-dipole strong? Yeah, go together. How do you make them strong? If the molecule is more polar, okay? If you have a greater negative, greater positive, what happens, guys? It becomes what? You have a stronger dipole-dipole interaction. So the strength of a dipole-dipole depends on what? Depends on the polarity of the molecule, okay? So, dude, there are some very strong or very polar molecules, such as what? You probably heard it, right? Like these guys, H2O and H3, like HF. These are very polar molecules, okay? Which can have a dipole-dipole, but what happens, guys? It's too strong as a dipole-dipole. They put a different name there, which is what they call it. What do we call this what, guys? Hydrogen bonding, right? Hydrogen bond, okay? I tell you guys, for the AP, you have to know exactly what makes hydrogen bond, okay? You gotta understand, guys, okay, so is it only between these guys or something else? Can anything else make hydrogen bonding? So again, you have to know exactly, guys, what are the criteria of hydrogen bonding. Very, easy but important, okay? So hydrogen bond is a subset of the dipole-dipole, okay, but extremely strong. That's why they gave the name to this, okay? I mean, it's extremely strong for dipole-dipole, okay? It's not that strong as a bond perspective. But now, yeah, know this now, okay? So the requirements. These are examples, okay, for 7th graders, okay? The example for the AP Chem, not example, but the definition is this, okay? Hydrogen, okay, so what hydrogen is eligible for hydrogen bonding? First, there must be hydrogen there, okay? Hydrogen must be present, so these guys have hydrogen there, right? Hydrogen, right? Hydrogens must have what, guys? Must be covalently bonded to what? Either nitrogen, oxygen, or fluorine. Okay? So listen to this, okay? The hydrogen that's eligible for hydrogen bonding, which is a very strong dipole-dipole interaction as a molecule, hydrogen must be covalently bonded to what? Either of these three guys. If not, they cannot have hydrogen bonding. Okay, that's the requirement for this. okay, for the hydrogen. So now, if hydrogen is bonded to a carbon, they're not eligible for hydrogen bonding. Okay? This hydrogen cannot be hydrogen bonding. So then also, so that's a requirement. Okay, so what about the other part? So and also the attraction is what? Then this guy is eligible. So the other party who's so this is what? One molecule, right? It's intermolecular force, right? The other molecule must have what, guys? Also, either must be an oxygen or fluorine or nitrogen. Okay? And now the oxygen must have at least 2 lone pairs of electrons. Fluorine should have at least what? 3 lone pairs. Nitrogen has at least what? 1 lone pair. Then hydrogen can what, guys? Be attracted to these either oxygen, fluorine, or nitrogen and create what, guys? Hydrogen bonding, which is dipole-dipole interaction. That's what? Really strong. So the example you're given a lot was what? Like these guys. Where, take a look at this. So water molecule, right? The hydrogen covalently bonded to the oxygen, okay? Right there, okay? And if there was another water molecule here, the oxygen has what? At least 2 lone pairs, okay? This oxygen will be attracted to the oxygen, right? Right there, that is what? Hydrogen bonding. Do you understand, guys? That is hydrogen bonding right there. That's the definition of hydrogen bonding. So, like, you gotta understand, like, can this guy have hydrogen bonding? Guys, that was true. Which, think about it, guys. Yeah, hydrogen 1, 2, 3, 4. Okay? Which hydrogen is eligible for hydrogen bonding? This guy. These cannot, because why? They're bonded to a carbon. This guy can, yes. And now, if this guy, if there's a water molecule next to it, what happens, guys? That right there is hydrogen bonding. So it's not restricted to these guys, like H2O, like NH3, or HF. Like stuff like this can be hydrogen bonding. What's I'm saying? So you gotta understand, guys. Like it's very simple stuff, but students really they don't get it. You know, until the end, until like the day of the AP. And I don't know. And so, any questions? No, so like, what was that bio, right? What was that, guys? What is hydrogen bonding, right? What was that, guys? The nucleotide bases. Okay, like you got like C and like what C and like what? So C and T, some C and G, A and T. How do they attract? How do they attract these two guys? Hydrogen bonding, right? That's what hydrogen bonding is, right? So that's hydrogen bonding right there. So you gotta understand, guys, what hydrogen bonding is. So the definition, guys. Any questions, guys? And also, can this oxygen have hydrogen bonding? Yes, they can. They can. I mean, they don't have hydrogen, but if there's what, guys? Nitrogen, like ammonia, for example, right? Like this hydrogen can have what? Hydrogen bonding with this oxygen. You understand what I'm saying? Okay? That's the minimum requirement for hydrogen bonding, okay? Which can create a very strong dipole-dipole interaction, okay? Any questions there, guys? It's good to know, okay? It's like something that you have to know for DP. So dipole-dipole, okay? That's like, dude, like, okay, so intermolecular force attraction, right? But again, if IMF is strong enough, if IMF is really strong, like hydrogen bonding is relatively strong, right? What's something that can result from the strength, what do you think? If the IMF is strong enough, what happens, guys? The phase, the state. H2O, what is it, guys? This is a liquid. If IMF is strong, what happens, guys? There can be found as well liquid or solids. If they're weak, what happens, guys? They'll be found as well gases. Okay, so that's something to understand, guys. So for example, what's CH4? They have no hydrogen bonding. They're what? They're gases. Because attraction between the molecules, if they're strong enough, what happens, guys? There can be found as a liquid or even a solid. Okay? For example, HF. HF, that's a liquid. Fluoric acid, hydrofluoric acid, it's a liquid. That's hydrogen bonding, hydrogen bonding. Alcohol is a liquid, hydrogen bonding. Okay? So, but this guy is a gas. CH4 is a gas. Why? They don't have a strong IMF. Okay? So, stronger the IMF, more likely to be found as what? A solid or liquids. Okay? The weaker it is, more likely to be gases. So, so every polar molecule, like these guys, right? This guy, like they can be what? They're technically speaking, they have both attraction, dipole-dipole interactions, sometimes hydrogen bonding, and will have attraction, and depending on the strength, they can be what? Yeah, found as well, like gases or solids or whatever. But now, the question comes down to what? Like these guys, non-polar molecules. So, I mean, if it's not your first time taking bio, taking chem, guys, you should know this. So, technically speaking, the definition of non-polar molecules is what, guys? They have no polarity. Okay, so for example, guys, CO2, right? The polarity is 0. There's no partial negative positive, which means what? There's no attraction between the CO2 molecules, which means they should be found as what? Gases. There's no attraction, right? They should be always found as gases. Here's what I'm saying. So yeah, they're gas. CO2 is a gas, yes, which is pretty good, right? But now, let's take a look at this. So this is where the AP is asking a lot of questions on. So now we have a fluorine gas, chlorine gas, okay, bromine, and iodine. What do you guys know about all this? F2, Cl2, Br2, these are what, guys? Diatomic molecules. All of them are diatomic. Guys, F2, like these are what? These are what, guys? All non-polar molecules. Everything's non-polar. Non-polar molecule, non-polar, right? Fluorine is a gas. No question, because why? Non-polar molecule have no polarity, no partial negative positives, right? Ideally, this is what? This is a gas. Cl2 is a gas. Bromine. Now, what's bromine, guys? This guy's a liquid. How about this one? This is what? This guy is solid. So the question becomes on the AP, why are they liquid or solid? That's the question they ask you. So, yeah, water is a liquid. Because why? Strong hydrogen bonding. HF is a liquid. Because why? Strong hydrogen bonding. Why are these liquid and solids when they're non-polar molecule without any dipole-dipole interactions? How can they be a liquid or solid? That's the question that you have to ask yourself, guys. So what kind of IMF do they have is a question, okay? And the answer is, of course, you guys should know, right? LDF. It's called London dispersion force. In bio, they used to call this what? Van der Waals force of attraction or something, okay? LDF, London dispersion force. You have to know this, guys. This is something that's really important to know. Even if you write it LDF, so AP, right, college perspective, if you write them as LDF, okay, they're gonna make it right. Like they should know what it is. Okay, you don't have to write it out as London dispersion forces. You can write LDF. They should know what it is in testing. So you have to understand what this is. LDF, London dispersion force. What the hell is that? And how like this can be so strong enough to make these guys into a liquid and solids? So let's discuss. So so LDF, okay. Let's compare this guy or this guy to that guy, F2 to a Cl2. So F2. So F2 looks like this, and Cl2 guys, so I2 guys looks like this. Okay, they have a lot more electrons compared to that guy. Okay, the term is that you have to know is what? Momentary dipole. Okay, momentary dipole. So what it means is this, okay? As we know, electron is not static. Electron does not stay in one spot. Okay, that's what Thomson's model, right? Electron is a wave, they move around. Okay? So now the question becomes, okay, so if they move around, what happens, guys? I mean, at one point, so this is like simple, right? At one point, okay, you guys are like, dude, like, obviously, right, entropy, based on the entropy perspective, right, electrons should be what? Evenly spread out, okay? But, okay, so, like, for example, guys, if you guys get on a bus, people should, evenly spread out. Is that the case, guys? No, typically, like, people congregate near the doors, right? So, that's what it is. So, electrons at one point, okay, by chance, momentarily, what? They can be found more on one side compared to the other side, momentarily. Which in case what? Which means what? Yeah, like temporarily, what happens, guys? You can create what? Partial negative, partial positive. Not permanent dipole, but what? Momentary dipole. okay, based on what? The movement of the electron and what? The position of the electrons. And now, okay, if they do this, what happens, guys? If the neighboring molecule does something similar, what happens, guys? They'll attract, okay? Based on the momentary dipole, if there's attraction, what happens, guys? That's what they call LDF, London dispersion force, okay? And now, so yeah, so one thing to understand, guys, is this, okay? So I'll explain it later. So LDF, right? So non-polar molecules can have LDF, right? So now, what about the strength of LDF? How do you make it strong? How do you make this LDF like super strong? What's something that you can do? So the strength of an LDF depends on what, guys? The size of the molecule, okay? So I tell you guys one thing. I can guarantee you guys, I guess a lot of you guys, or some of you guys, okay, I'm not sure, wants to be doctors, right? Wants to be doctors and pre-med in college, guys, just so you know. What I'm gonna say right now, guys, okay, it could be different based on the test makers, okay? So, but I'm gonna stick to the AP, the College Board, how they were phrasing this, okay? So LDF, London dispersion force, on the MCAT, for example, guys, they call this Van der Waals force of attraction, by the way, okay? So different test makers have different terms. So if you want to have a strong LDF, okay, which means what? Then which means you have to have a strong momentary dipole. To do so, you have to have what, guys? More number of electrons. So greater the number of electrons, stronger the momentary dipole should be. Okay, so which means what happens, guys? I too have more electrons, which means what, guys? More electron can shift to one side at one point, which means what? Which can create what? Bigger momentary dipole. If it does that, what happens, guys? You can have what? Strong momentary dipole and what? Have a stronger LDF. Okay, so if the question asks you guys, okay, so between this guy and that guy, okay, why is that a solid and why is this a gas? Would your answer be what, guys? I2 has a stronger LDF because I2 has what? Greater number of electrons, okay, which can create what? Stronger momentary dipole, okay? Or you can say, if you have a greater number of electrons, you can be what? It's a terminology of the College Board, they like to use what? They're more polarizable. Which means what? Means what? Yeah, they can shift, more electrons can shift to one side, have a stronger momentary dipole. In turn, becomes more negative, which means what? They can have a stronger attraction, something that's more positive. That is basically what LDF is. So all in all, what you should say is what? Yeah, like more electrons, greater size electron cloud, stronger LDF, because what? They're more polarizable. That'll be the AP. That's how the College Board wants to explain this. If you're taking the MCAT, I guarantee you guys, okay, if you take the MCAT, that is not how the answer should be, like, it's multiple choice, right? So that's not how the answer key should be phrased. It's on the MCAT, they will say, I2 is solid because it's a bigger molecule. That'll be the answer. Okay, so just so you know. So different tests have a different understanding and different logic based on the answers, by the way. But again, we're taking AP, so we gotta stick to the College Board understanding here, okay? So all in all, this is what I'm saying, okay? Larger the molecule is, whatever it is, okay, they have more electrons, which means what? They should have what? Stronger LDF. That's a simple term. So in terms of a dipole attraction, IMF, right? More polar molecule attracts stronger, okay? Stronger IMF, right? Dipole attraction. And if it's strong enough, you can hydrogen bond it. In terms of LDF, what happens, guys? The larger atoms, larger molecules have what? Stronger LDF. Because why? They are more polarizable. I forgot which year, guys. I think one of the questions on the AP, they asked about induced dipole. They asked about what induced dipole is. So induced dipole is what, guys? So for example, right? So for example, guys, if, right, there is a positive charge ion there, nearby there's a positive charge ion. right? Like near I2. What do you think will happen? Now, what do you think will happen, guys? What do you think? Electrons will be what? All gathered on the positive charge electrons. So all the electrons will be more on this side. You understand, guys? Which will induce polarity within the molecule, partial negative here, partial positive, induced by what? This charge. That's what they call induced dipole. Okay. So yeah, so I think that's one of the terms that I've seen in the past EP. So it's good to know. So yeah, listen very carefully now. So what you guys have to understand is this now. So should then only non-polar molecules should have LDF? What do you think, guys? That's the only case, guys? What do you think? No. Any molecule, any even atoms that has electrons, okay, if you have electron, you can have LDF. You know what I'm saying, guys? Here. So that's one of the things about the AP. So, meaning, guys, like you got to be very clean cut here. So what I'm saying is, guys, LDF is something that can be, something that any molecule of the atom with the electron can have. Okay. So if you have, for example, guys, let me give you an understanding, guys. So when you have, guys, PCl5, okay, I mean PCl, I'm sorry, not PCl5. NCl3 or Ni3, okay, versus, I'm just making this up, okay, NH3, okay. So when you draw this out, okay, when you draw this out, guys, so first thing first, we have to understand what? They themselves can have what, guys? Hydrogen bonding. NH3, ammonia, have hydrogen bonding, right? But keep in mind, hydrogen bonding, you think it's really strong, right? NH3 is a gas. Ammonia is a gas. So, even though they haven't bonded, they're gases. Let's assume this guy is a solid. Okay? This guy does not have hydrogen bonding. They don't have hydrogen bonding, right? The question can ask you in the EP, why is this guy a solid at room temperature when this is a gas? Then what will be the answer, guys? But if you draw the structure, I mean it's not hydrogen, it's iodine. And this is hydrogen, right? So this guy can make hydrogen bonding, they cannot. Okay? But why does this guy have what? Greater boiling point, or become solid? Now, keep in mind, when this is a solid, what does it mean, guys? They have a stronger LDF, no question. Okay? So LDF, strength of LDF will decide their phases, no question, guys. So if that's a solid, it's a clean cut thing of what? Their IMF for this guy is stronger than the IMF for this guy. There's no question. And they will ask you guys, why? So, and now the AP question will ask you, okay, write all the intermolecular force present for this guy versus that guy. Okay, write all the IMF. So this guy is what, guy? This guy has, it's a polar molecule, has dipole-dipole. And also what? Also what do they have, guys? They also have what, guys? They also have LDF. So LDF is what, guys? As long as they have electrons, they have an LDF. Okay? London dispersion force applies for every single thing that has electrons in it. Okay? If you have more electrons, you have a stronger LDF. But this guy, they have what? Hydrogen bonding. And also what? They have LDF as well. You know what I'm saying, guys? Hydrogen bonding and LDF. But the question is, dude, my question is what, guys? Yeah, why is this guy a solid? Why that guy is a gas? Why? Because why? I mean, we understand dipole is what? Weaker than what? Hydrogen bonding. This guy wins. Why? This guy has what? Much stronger LDF. That's the reason why that's a solid. Because why this guy's a stronger LDF? Because why? They have more electrons as a molecule. If you have more electrons, they're more polarizable, stronger LDF. That's why this is solid. That's the EP, guys, So LDF doesn't apply. So dude, like last year, whatever came you took, guys, LDF, a lot of times from the SAT level, it's restricted to nonpolar molecules. Not the case. AP, guys, it could be multiple. Okay, you can have dipole, hydrogen bonding, and LDF. Okay, it's a mixture of all. And in this case, guys, LDF, strength of LDF supersedes the hydrogen bonding, okay, and the LDF together. That's why they have a stronger IMF overall. That's why they're solid versus a gas for NH3. Okay, that is cause where the question they can ask you. No question is, and this is very important, guys, IMF perspective. Every year they have this, guys. Yeah, and you'll see the questions in homework as well. Any questions, guys? If you don't know, guys, like I don't understand what this guy's saying, but you gotta let me know. Okay. Any questions, guys? Any questions, guys? Let me know. All right, so that's it for this episode, okay? So, so there'll be a homework assigned to you guys. I forgot how many questions, like 40-something questions, I think. Multiple choice. Quick, simple. If you understand what the hell is happening, guys, it shouldn't be a problem for you guys, okay? Yeah.
Wait, it's emailed to us, right?
Hmm?
The homework is emailed to us?
Online.
Alright.
It's online. The reading was emailed, but homework is something else, okay? Any questions, guys, let me know? All right. I mean, dude, it's summer, okay? So I don't want to kill you guys with these stuff, guys, you know, but, you know, I mean, there's more detail, but I'm not going to go any more crazier than this right now. I'm just touching the important parts right now. All right. Did I miss anything? I saw the questions. I don't think it's gonna be very difficult, guys. Oh yeah. I'm sorry. I gotta. So the next 10 minutes, guys. I have to discuss the AP Attic guys metallic bonding. So I forgot that. Okay. So metallic bonds. I mean, it's not like they never were there, but they ask a lot more questions now. Metallic bonding. And what else? Yeah. So metallic bonds. Okay. So for example, guys, how is this possible? This is a metal, right? So how can like we have this? So how they're solid? I mean, if they're solid, which means what? There must be some attraction there, right? Like how this? What this one? Like laptop, right? You know, so like they call this what aluminum chassis or something. Your Apple stuff, whatever. This is not Apple, by the way, but the aluminum chassis. You know, so how are they solid? Solid means what? They have a strong bonding, right? So how is that possible, right? So metallic bonds, like piece of block of iron, for example. I don't think I have to know too much, but they start to add some crap in here that I don't know. So the metallic bonds, okay. So keep in mind, guys, they have protons, like nucleus, guys, just sitting around, and the valence electrons can what, guys? Just like float around. Okay, what do they call this, guys? Sea of mobile electron something, guys. You know, so electrons can what? Move around. Within this, freely move around, okay? So now, the electron between the nucleus, okay, which force creates attraction, that's the metallic bonding, okay? So if you think about it, right? Typically, okay, within the same group, smaller the atom is, I mean, just like a high level for the AP perspective. If the atom is small, what happens, guys? Like, dude, like these atoms can get close together, which means what, guys? They can have stronger metallic bonding. So now, meaning, guys, if you look at the same group, for example, like lithium, like whatever stuff, that goes down to CS. So lithium should have a stronger metallic bonding compared to what, guys? Cesium, francium. Do you understand what I'm saying? Okay. So because why? They're more tightly packed. They can have what? Stronger metallic bonding. Okay. It's obvious, right? But now, that's not it. Like, okay, so that's more of an Olympiad question they ask you, like, oh, strength of metallic bonding. But now, yeah. So one of the things they ask on the AP, like, is like, they ask about the alloys. Okay, they ask about the alloys. So alloy is what, guys? Alloy is like this. This is I don't know what this is. So like the alloy is what? Example is steel is alloy. Okay, like your laptop, like metal is an alloy. Okay, alloy is a mixture of a metal. Okay, you put two metals together. Okay, so for example, guys, like if you guys go buy a gold ring, okay, like the white gold, right? So white gold is what, guys? Like it's mixed with like what? Like what? The gold and like some crap in there. Okay, that's just they mix them white. Like platinum, for example. You guys got married, guys. Make sure you guys get a platinum ring, by the way. Like no fake white gold. So platinum ring, right? So again, like how do you know you got a platinum ring, guys? Inside this is what they say, like P like 950 or something. It means a 95% pure platinum, the 5% something else. Okay. So now, What about the 5%? Like, what do they use there? You know, that's what it is, right? So it's an alloy of what two different metals, right? So they talk about the alloy in the AP Chem, okay? So now there are two. So this is a shitty question. I tell you, man. Like, I don't know why they ask these questions, guys. They get the students get this question wrong. So there are two different types of alloys, okay? One is interstitial alloy, okay? The other one is substitutional. Interstitial and substitutional. Okay, so let's talk about what it is. So let's talk about, guys, the platinum alloys. Okay, yeah, platinum is a very large atom, right? The platinum is a very large atom, right? Which means what? There's a lot of space in between the two. You understand, guys? There's a lot of space, okay? Which, like, just like gold, right? Gold is a large atom, right? So what happens to gold? Like when you guys, like, Olympic is going on right now, right? So what do they do when they win gold medal? What happens, guys? They bite into it, right? Why? Wait, why? If it's a pure gold, their attraction or the metallic bond is so weak because the atom is large. What happens, guys? They're so soft. Okay, you can bite in. That's how you know you got a pure gold, right? So you don't want your jewelry, like the rings, like you punch it, like you don't want to, like, you know, deform, right? So what do they do, guys? They put something in there to strengthen. Okay, and that is what example of interstitial alloy. So which means what, guys? They put something in there to fill the gap. Fill in the gap, okay? Which is a small, tiny atoms that fills in the gap, you know, whatever that is, okay, like copper atom maybe, you know? And then what? Strengthen the gold atom, a gold-like metal. Okay, that's what we call what? Interstitial alloy, okay? So you know. And now, you should understand, guys, like if you look at, guys, like 14 karat golds, okay, 14 karat as well, like, dude, they're not expensive, right? They're pretty cheap, right? So this is basically what, to low, could be one of the reasons to lower the cost of a metal. What happens, guys? They replace the gold with a similar size atom, such as what? Silver. Okay, silver, Ag. So that's what they call what? Substitutional alloy. Okay, so so the difference is what, guys? Interstitial is what, guys? Yeah, they're putting something in that's a smaller size. This is what, guys? They're putting some alloy in that's what, in similar size. Okay, like gold and silver, for example. They're very similar in size, by the way. Okay, so they talk about these garbage stuff, okay, on the AP. Okay, you gotta know, if you don't know it, guys, your teacher very unlikely to teach this, by the way. Okay, like I don't know what school you guys go to, I forgot, but very unlikely they will talk about these guys, by the way. You gotta know what they are. They talk about this. Okay, you gotta understand, like, dude, like they talk about steel. I mean, a lot of them is just, I don't know, like, dude, a lot of them, guys, is based on like common sense, I think, some of the questions. You know, but the terminologies, like these two, I want to talk about it. Just want to make sure, guys, you understand what it is. A lot of them didn't talk about metallic bonding, by the way, but there are definitely questions on this that you might have to know. Okay, so like steel, for example, like galvanized metals, like they talk about it, you know, but I don't know. Like I don't think you'll see some questions in the homework. You can look it up, whatever, on Google, whatever, you can do whatever you want to do. But we'll talk about it, guys, a little more about this when we see the questions you know, to ourselves when we go over homework questions again. But yeah, that's, I think, about it. But other one is maybe, guys, you might have to know the network solids. Okay, such as like diamonds, you know, like glass, silicon dioxide, for example, guys. That's one of the things that's in the scope of the AP as well. But I mean, I'll squeeze this in, guys, for the homework questions. Okay. So, guys, I'll sign the homework, guys. I can tell you guys. I'll send the email and the link, guys. You know, for the homework. You guys should know where you should go, guys. I mean, it's about like 40. You found them missing. I saw this morning. It's about 40 questions, I think. Okay, so it's not too bad. Multiple choice. You know, I'm not gonna add up FRQs. So it's gonna be pretty quick, guys, for you guys if you know what you're doing. Do the chapters, and that's gonna be it. Okay. All right, guys. I'll talk to you guys next week.